So hello, class. We are continuing on, uh, pressing forward with moving through the book. We are in chapter 6 now, talking about bones. You remember, uh, you may remember when we first were talking about the skeletal system in chapter 1, talking about the different systems in the body. Uh, we're going to talk about bone and its role that it plays in movement, its role that it plays in structure and support of the body, also making blood cells, other aspects of the bone and the whole skeletal system. Very important system in the body, obviously. If you didn't have bones in your body, we would be blobs on the floor. And so it's good that we have bones. All right, let's get going. All right, so this is the introduction, 6.1. All right, so what does the skeletal system include? It includes bones, joints, and supporting structures. You may, when you think of a skeletal system, think of the bones, think of the joints, think of tendons. We're going to, relate closely to the muscular system because the muscles and the bones sort of work closely together. So think of ligaments and tendons as well. When you think of skeletal system, even though tendons connect your muscles to bones, ligaments connect bones to bones. And so whenever you see the term osseous, osteocyte, osteoblast, osteoclast, osteoporosis, think of related to bones, just like cardio is related to the heart, pulmonary is related to the lungs, urinary or renal is related to the kidneys and the urinary system. When we see osseous, osteo, we're related to bone. And bone, if you remember from our tissue chapter, I believe, chapter 4, dense, regular, and irregular collagenous connective tissue. All right, and we also have bone marrow that we're going to discuss. All right, so what is the role of bone in the body? And some of these should be very familiar. Shouldn't be too much of a surprise for some of these. Right, so obviously we know it's protection. Think of your brain. Your brain is protected by bone that is your skull. Your vertebrae protects your spinal cord. You remember that when we talked about the nervous system. Your rib cage protects your vital organs, your heart, your lungs, your stomach, things like that. So we have a lot of protection from bones. Another function of the skeletal system is mineral storage, acid-base homeostasis. So we're going to talk about in this chapter specifically calcium, but there are other minerals stored in bone, calcium being one of the most vital. Calcium is needed for different functions in your body. We talked about the endocrine system and how if your calcium is too low, we talked about the parathyroid hormone and calcitonin and how they regulate the calcium in your blood because calcium is very important. Well, your calcium is stored in your bone. So your bone helps with your mineral storage and your acid-base homeostasis. We also have blood cell formation, right? We're going to talk about bone marrow, red bone marrow, and yellow bone marrow. All right, red bone marrow, that's where we have formation of our red blood cells, which is very important because red blood cells carry oxygen by the hemoglobin that's in the red blood cells carry oxygen to the body. So without red blood cells, we would not be able to get oxygen to our tissues, and therefore we would have difficulty living. All right, so those red blood cell formation, hematopoiesis, happens in your red bone marrow. We also have some fat that's stored in your bone. Yellow bone marrow stores some triglycerides, right? So remember fat cells, adipocytes. Cyte is cell, adipose, fat cells, adipocytes. So remember that. So you have some fat storage in your bone. Right. As I mentioned earlier, movement, muscles attached to your bones. That's how we're able to move. We have a lot of support. You're able to stand up because we have this support structure built into our bones. It provides a framework for the body, sort of like like when you put up a wall, you put up these 2x4s and nail them together and create this structure, and then you attach the drywall to that structure, sort of the structure that would be your bones, right? And that's a diagram just putting all those together. So protection, mineral storage, blood cell formation, fat storage, movement, and support, all functions of the skeletal system. Right, now we're going to go into the actual bone structure. As you see here, I have highlighted 206 bones, right? 206 bones. I would like for you to know all 206, but you don't have to know all 206 for the purposes of this class. But that wouldn't be a bad thing to learn your bones, your nerves, your muscles. Those things are, especially if you're going to continue on in the medical field and be a medical professional, especially if you're going to be any type of medical doctor. You will have to know most of the bones, the nerves, the muscles, obviously all the major organs, all the organs really, but obviously the organs as well. Okay, so 206 bones in the body, all right? And I'm going to require you to know some of them, but not all of them, right? So we have different categories of bones, basically based on their shape, all right? So long bones, longer than they are wide, right? These are usually the bones that we think about when we think about bones. The humerus, for instance, in your arm, the femur in your leg, right? Long bones. We also have short bones. If we have long, we have short, which makes sense. Short bones, roughly cube-shaped or as long as they are wide, right? Your carpals and tarsals, those are the bones in your hands and your feet. We have flat bones. Everybody knows the sternum right here in the center of the chest, sort of where your ribs are connected to, and that is considered a flat bone. Ribs are, as well as the pelvis, are considered flat bones. Okay, so broad, flat, thin bones. We have irregular bones, the vertebrae, your spinal cord, where your spinal cord is contained, your vertebrae. They help protect the spinal cord. They're irregularly shaped bones. We also have sesamoid, I'm going to say that wrong, sesamoid bones, specialized bones, located within tendons, usually small, flat, oval shaped, right? An example of this is your patella, which is your kneecap, right? And these are just your different bones, where they're located in your body. As you notice, we mostly focus on your long bones, right? Humerus, ulna, your femur, your fibula, tibia, right? We focus on those. We also have the pelvis, flat bones, your vertebrae, and the spinal cord, protecting your spine, irregularly shaped bones, your ribs flat, your sternum flat. Okay, so all different types of bones that are located in different parts of the body. Further looking at the structure of bones, see if I can fit my face in here somehow. All right, so let's talk about the structure of specifically the long bone. All right, so there's long, there's short, there's irregular, sesamoid, different flat bones, so different types of bone, but specifically the long bone, which is one of the major structures that we're going to focus on. We have this, on the long bone, we have this dense irregular collagenous connective tissue that is on the surface. And that's going to have your blood vessels and your nerves. That's the periosteum. Then you have the perforating fibers, also known as Sharpie fibers, made of collagen, which anchored the periosteum to the bone, to the actual bone. The bone then has we call the long shaft. So this this long portion in the middle, we call that the diaphysis, this long shaft. We call the ends of the bone, both ends of the long bone, we call that the epiphysis, right? And so the diaphysis is a long shaft. The epiphysis is the end of the bone. At the end of the epiphysis of the long bones, we have what we call articular cartilage. This is where you form the joint, right? So at the end, you have cartilage is blue, look like this whitish blue cartilage. That's where you form the joint with the next bone. So that's where you form articulations or joints. Is at the articular cartilage. It's like a cushion between one bone and the next. And then inside the bone, you have yellow or red bone marrow. Red bone marrow is where you have the formation of your red blood cells. Yellow bone marrow is where you have some fat storage, and that the amount of red and yellow bone marrow can change based on your on your age. Okay. Two different types of structures of bone exist. We have compact bone, which is your hard, dense outer region of your bone. So that's the bone that resists linear compression. So linear compression is like if I have the bone and I'm pushing this way, I'm trying to compress it. Your compact bone is what is going to resist that force, a strong force. That makes bone very strong in linear compression. It's very hard to physically compress bone and break it. But also we have what we call spongy bone. So both of these are in long bone, compact and spongy. So we have more compact on the outside, superficially, and then more spongy bone on the inside. What spongy bone allows you to do is resist forces coming from different directions. So I have forces coming from, pushing different directions at the bone. So with this hard outer structure and soft inner structure, I can resist forces from all different types of directions. Obviously, bones do break, but we don't want that to happen. Continuing on with the structure of the bone, we have, all right, so the bony struts of the spongy bone, all inner surfaces of the bone are covered by this thin membrane called the endosteum, all right, so which contain different populations of bone cells. We're going to talk about the different bone cells that are involved. We're going to talk about the osteoblast, the osteoclast. So that's on the inner surfaces of the bone, right? And then we also have this epiphyseal line, right? Separates the proximal and distal epiphysis from the diaphysis. So going back to this, we have the diaphysis is the long shaft. The epiphysis is the end, and between the epiphysis and the diaphysis, we call the epiphyseal line. That's going to be important because that's where our growth plates are, right? So our bone is going to grow this way, primarily, all right? So that's where our growth plates are. And eventually bones stop growing, and that line sort of ends, that growing ends, that epiphyseal line ends, right? So we'll talk about that as well when we talk about how bone grows and develop in our development, right? But notice that epiphyseal line is going to be at the proximal and distal at the ends of the diaphysis, right? In comparison, short, flat, regular sesamoid bones do not have diaphysis, epiphyses, medullary cavities, epiphyseal lines, or epiphyseal plates. They are covered by the periosteum. Remember, they need this blood supply and the nerves, right? That's where the periosteum, they have the Sharpie fibers, the perforating fibers, and blood vessels and nerves. They tend to have the internal structure of compact bone on the outside with the inner deeper. If you go deeper, we have the spongy bone. And we also have some flat and irregular bones that have what we call sinuses. We notice that in the skull, where we have holes in the bone on purpose in order to reduce the bone weight. If you didn't have holes in your skulls, your head would be much heavier, right? This is a structure, bone structure, showing you that. Some other types of bone, periosteum, notice blood vessels, nervous tissues in your periosteum. We have the collagen, the perforating fibers connecting your periosteum to your bone. We have the actual compact bone, spongy bone, more compact bone. This is the general structure of a short, flat, irregular, or sesamoid bone. Right, talking about a little bit more detail about the blood supply and the nerves. Your short, flat, irregular, and sesamoid get most of their blood from the periosteum, whereas for long bones, they get a third of their blood supply from the periosteum. These are bigger structures, but the remaining 2/3 come from what we call the nutrient artery, which enter the bone through small holes through a small hole in the diaphysis, the nutrient foramen, right? So that's going to supply blood to the compact bone and the internal structures of the bone. Okay, so a little bit different blood supply based on if it's a long bone, which is a bigger bone, versus the short, flat, irregular, and sesamoid bones. The bone marrow, as we talked about, is a little bit different as well, right? So we have the red bone marrow, which is going to produce our red blood cells, which is very important for our cardiovascular system. Red blood cells last about 120 days, so we have to constantly be making red blood cells. But the amount of red bone marrow decreases as we get older because children are doing a lot of growing. They need a lot of red blood cells, and they need more red blood cells, the higher production of red blood cells. As we get older, we're not having as much growth and development, so our bodies don't require as much red blood cells as we do when we are younger, and the body's growing and needs that constant influx of oxygen and red blood cells, right? This may also explain why kids continue to run around, because for some reason my kids do not stop. Maybe it's because they produce more red blood cells. I have to do some investigative report on that. But continuing on, yellow bone marrow, which is fat, is you have triglycerides. Remember triglyceride, glycerol, with 3 fatty acid chains connected to it. Blood vessels in your yellow bone marrow, blood supply to your that nutrient artery. And you also have adipocytes, which are your fat cells. They contain a lipid inclusion in the cell, your adipocytes, right? So that's all in your bone structure, right? So epiphysis, diaphysis, those terms. No nutrient artery. Know about the nutrient artery, the artery that travels inside of the long bone. Know about the periosteum on the surface, supplying blood, nerves on the surface of the bone, and the primary blood supply for the short, flat, irregular sesamoid bones. Know the epiphyseal plate, that's at the end of the diaphysis, both ends. That's where we grow from until we reach a certain age, and that closes up. And know about the red and the yellow bone marrow. Know these different terms, all right, as we discuss different bones. If you want to start learning all 206 bones, feel free, put those on flashcards and learn it. Also, the articular cartilage on the ends, all right? So that articular cartilage is going to be very important when we talk about forming joints, connecting one bone to the next. All right, just a little real life situation, medical application we have here is the bone marrow transplantation. Right? So people with leukemia, sickle cell anemia, basically their red bone marrow is not correctly producing red blood cells. I know this firsthand because I know my wife suffers from sickle cell anemia, and so what happens is that if a matching donor, right, somebody who will, their body, they'll match, they're a good match, what they do is they withdraw healthy red bone marrow from one person and introduce it intravenously into another, and hope that it takes, basically. Those cells travel to that person's bone. So we kill off, so they kill off the bone marrow in the unhealthy person, kill off their bad bone marrow, take some from another person, put it in to that person, and hopefully it takes within 2 to 4 weeks. They put it in your body and it travels to your bones and gives you healthy red bone marrow so that your body can make red blood cells. Obviously, killing off your bone marrow is not a good thing to do, considering that's where you produce your red blood cells. So you're going to need some blood transfusions. It can be very problematic, but it could save your life. And that is the end of section 6.1.